Thank you. Other questions, anyone? Perfect. So now let's, again, you can always stop me. So let's look at any problem you'd like to, from 5 through 46 for now.
Oh, 30.
I couldn't hear you.
30.
30. Very good. Let's start with 30. I'm on page 4 and 30. As always, keep an eye on what I'm doing. 15, the indefinite integral from 15 e to x over 3 dx. Perfect. Awesome. Good. This is a constant. So the constant is, you know, from the derivative, from the limit, from all of these, if it's factored, if it's a factor, if it's multiplied, if it's plus, I cannot do anything, but it's multiplied, it can wait outside patiently. Always remember, x divided by 3 is the same with 1/3 times x. Because it's x over 1, 1 times x is x, 3 times 1 is 3. So it is very helpful and useful to remember this. Okay, so can anyone give it a shot? It's okay if you're wrong. So I have to copy 15. I have to copy e to x over 3. And I have to write plus c.
So x to the third. Yeah. X.
Let's do this again. If the number in front of x is 10, we only needed to put 10 in the denominator. What is the number in front of x now?
1 over 3.
Excellent. That's it. That's all we need to do. Let's say, really? Okay, let's differentiate this. 15 stays. E to x over 3 prime is e to x over 3 times 1/3. And I'll simplify 1/3 with 1/3. And this is 0. So we have to clean this up a little bit. Because remember, when we divide by a fraction, we really multiply by the multiplicative inverse. And we get 45 e to x over 3 plus a constant c. You can always say, stop, show me. All I need to do is differentiate this and show you that it's that. Let's do it. Check. I want to check that 45 e to x over 3 plus a constant prime will give us this. If it doesn't give us this, then we will say, oops, something is terribly wrong. Okay. When I differentiate this product, I have to copy the function. I differentiate e to x over 3 times the inner function prime. Constant prime is 0. I simplify, and I get 15 e to x over 3. So when it comes to the indefinite integral, because there is a second type of integral, the indefinite integral, it's always easy. I don't need anyone to tell me whether this answer is correct or not. I can do it on my own. I can check on my own. I differentiate this. If I don't get the function that I started with, I know it's wrong. Very good pick. Thank you. Next. Let's work on another one. And then let's look at our problem.
22.
22. Let's look at 22. Perfect pick. 22. The indefinite integral from 4 over x cubed plus 7 over x dx. Perfect pick. Thank you. Okay. So One of the properties, and we don't even need to talk too much about it, is like we had before, right? So if I have f of x plus g of x, and I want to differentiate, I differentiate f and I differentiate g. The same thing here. If you want to separate it, you could say, like here, you could say the indefinite integral from 4x cubed dx plus the indefinite integral from 7 over x dx. I just wanted to emphasize that that is possible if that helps. Of course, if I have minus here, I will have minus here. Same idea. Okay, there is no need to do that. I just wanted to emphasize that it's possible. Because why I said this? Because these are slightly different and I would like to present them differently. This one, first of all, we always have to remember we started this in chapter R. This has to be changed into 4x to negative 3 in order to find the most general antiderivative or the indefinite integral of this. However, for this one, I will not do this because I already know what function gives us the answer here that I differentiate to get 1 over x. I know that for sure. I don't need to. This is the only one I don't need to do this for. And what will be the answer here? And we just had that a few minutes ago, maybe 20. And somebody perfectly gave me the answer. I think it was Naja or somebody else.
Natural log, okay.
Yes. So it's natural log of the absolute value of x plus a constant c, of course. Yeah, with a 7, who cares? Okay, it's 7 in front. So there is a 7 in front. So I want you to understand that these two have to be treated differently. So I'm going to copy it from the beginning. So the integral from 4x to negative 3 plus, you can write it as 7 times 1 over x. You can always rearrange the function the way you like, or the way it's easier for you. And it's easier if I write the function like this. Okay, so now we already know the answer for this. So at some point I will have 7 natural log of the absolute value plus a constant c, because we already discussed it. But now, what do I do with this? Of course, I keep the 4 in front times what? And this is the power rule that we just talked about. Same power rule, no matter what power I have here, positive or negative, it doesn't matter. The rule is the same. So what will I do to get, what function do I differentiate to get that?
X to the negative 2?
Yes, over that number, exactly. So we are adding 1 to the power, and we have to automatically always divide by the same number. And now you can say, show me. I don't trust this. Well, let me finish it. So I will simplify as negative, because I have a negative in front, right? So it's 4 over 2, so it's negative 2. 1 over x squared plus 7 natural log of the absolute value of x plus a constant c. If you say, show me, I don't trust this. Okay, let's check. 4 over negative 2 is still negative 2. I have to differentiate this. I bring down negative 2, and I simplify with negative 2, and I subtract 1 from the power. So I still come back to 4x to negative 3. Plus, I differentiate this. It's 7 is a constant in front. It's a factor. There is nothing I can do to it. And natural log of the absolute value of x is 1 over x. And now I differentiate c, and I get 0. Good. Can we move on to a word problem, or we still want to? I want to look at this set, of course, but do we need another problem from here? Choose anything. Yes?
Professor Lee,
Yes.
We always have to have that plus C.
Because it's the most general antiderivative. Yes.
Okay.
Yes. So the indefinite integral, very good question. So the most general antiderivative always has the constant C because it will give us infinitely many different functions. If I omit this, that's only one function. This is the most general, which is a family of functions, infinitely many. So the indefinite integral will always have C at the end as the answer. Good? Okay, anything else you would like to look at? I would like to look at one of these. Can anyone choose? Okay, I will choose 39. I guess it was my turn. 3x squared plus 2x plus 5 over x squared dx. Notice one thing. There is no indefinite integral without the symbol, the function, and dx. These three pieces. Even if the function is just 1, the integral of 1 dx, okay, or just a constant, it doesn't matter. The integral symbol, the indefinite integral symbol, the function, and dx. Not the other way around. It's not a big deal, but that's how we write it. The integral from f of x dx. Can anyone give us an idea of what to do first before we even think of finding the indefinite integral here? What would you do? Remember the keywords. And I'm going to add one more. Inspection. Inspection. Factor. Simplify.
Turn x squared into negative x squared, or sorry, x squared minus negative 2.
I will not be able to do much with that.
So
Okay.
simplify. I say simplify.
Yes, how?
We can extract them like 3x to the 2 over x to the 2.
Separate,
2x.
very good. Separate the function or the ratio in 3 fractions. Very good. This is always possible because the denominator is one term. If the denominator has plus 1 or minus 5x or whatever else, more than one term, we cannot do this. But we have to separate the function into, or the ratio, rational function if you want, in 3 different fractions. Awesome. This is exactly what we need to do first. 3x squared over x squared is 3. 2x over x squared is 2 over x. And 5 over x squared is 5 over x squared dx. One more time. 3x squared divided by x squared is the first fraction, which is 3. Second fraction now. 2x over x squared, simplify 1x, 2 over x. Third fraction now, 5 over x squared. This is fixed, but this has to be replaced by 5x to negative 2 to make our life easier. So I'm going to do that. And can anyone give us the answer afterwards? So the integral from 3 plus 2 over x plus 5x to negative 2 dx. Can anyone give it a shot? It's okay if you're wrong.
I can give it a shot.
Yes.
It's 3.
So careful. Which function prime is 3?
Oh,
right? It has to be 3x, right? Because 3x prime is 3
Oh, yeah.
plus
Plus natural log,
the
2
2.
natural log of x,
It has to be the absolute value.
absolute x,
Good.
and then plus 5x to the minus 2 over
Minus 2 plus 1.
Minus 3 over
Minus, I know it's confusing.
minus, yeah.
We are going backwards. We're adding now.
Oh gosh.
That's okay. That's okay. That's why I said we have to
I
get used to
tried.
it.
I tried.
Yes, you're doing very well. So 3x plus 2, natural log of the absolute value is 5 over negative 1. So it's negative 5 over x plus a constant c. Good. Now, before we look at a word problem, I'd like to look at this set. So let's choose one from this.